Hi guys, welcome to another episode of MrLopezClasses.com. We are going to continue in our book of marine composite materials. And in the previous class, in the course of corrosion, I explained the difference in between organic and inorganic material. We are going to refresh quickly that concept, and we are going to continue dedicated only to the organic materials. We are going to continue into the organic chemistry, the study of carbon and other elements around carbon. Okay, my friends, organic and inorganic materials. Organic materials are made from plants and animals. For that reason, they are organics. Inorganic materials are made from rocks and minerals. Now we are going to check the main difference in between minerals and metals. Organic materials include wood, paper, textiles, animal parts. They include natural materials that, of course, they are organics, and they are coming from fossils, plants, and animals. Inorganic materials included stones, metals, ceramic, and glasses. Yeah, you remember we studied in details those ceramics. Some inorganic materials are found in paper-based formats, photographic, metallic particles, pigments, inks. Okay, we are going to check all of those because especially those pigments, those inks will be used to change the color of the resin in the fiberglass. What is the difference between minerals and metals? The majority of the metals, they come from minerals. A mineral is an inorganic crystal or compound. Was formed without the intervention of humans. Yeah, it's in natural form. For example, the native gold, the native iron, the native copper, the native mercury, quartz, diamond, graphite. Those are examples of minerals. And metals, metal is an element found in the left side of the periodic table. You remember, in this area, in the left side, are located the metals. And you remember the division on the periodic table? That division? From the left of the division is metals. From the right of the division is non-metals. Most metals, with some exceptions, gold, silver, and copper, they are founded like a compound because they are actives. Yeah, but except gold, silver, and copper, those metals, you founded those metals in natural form. And in this particular class, we are going to be analyzing the organic materials. What is the meaning of organic material? Is the study of the structure, the properties, the composition, the reactions, the preparation of carbon-containing compounds. All the compounds with carbon plus other elements like hydrogen, nitrogen, oxygen, phosphorus, silica, and sulfur is basically carbon study. For that reason, you divided the chemistry in inorganic chemistry, metals, non-metals, ceramics, glasses, non-metals, and organic materials is the study of carbon and other elements around carbon. This is basically carbon, organic chemistry. Physical properties of carbon. Physical properties of carbon. Is rigid, is high resistance to be corroded, is in some cases good electrical conductor, is excellent for fatigue, is a good tensile strength, but is brittle, easy to break. Fire resistance, is not flammable, and a high thermal conductor, excellent. And other important property, low coefficient of thermal expansion, wonderful. Is not poison, is inert, no react, is permeable to X-rays, is self-lubricated. You remember we used graphite like a lubricant. You remember the bellows stuffing box and the PPS stuffing box? Yeah, the color of graphite in permanent contact with the color of stainless steel. This is a great example. This is excellent for electromagnetic interference. In order to cover elements, in order to avoid that the electromagnetic interference attack those elements in alternators. It's expensive and require specialized equipment to manipulate the carbon. Don't forget, the carbon is located in the group number 4, carbon, silica, and germanium, those 3 elements called semiconductors, because those elements are in the division, in this division. You remember in this division where the metals are divided with the non-metals, carbon, silica, and germanium are located in the division. For that reason, they are called semiconductors. Semiconductors because depending on the temperature, those 3 elements work in some cases like metals, in some cases like non-metals. Be careful. When you have the structure of your boat in carbon fiber, that structure becomes metallic depending on the temperature. For that reason, in Caribbean, especially during the summer, the boats in carbon fiber, the structure becomes metallic. You need to be careful when you install, especially electronic equipment. Be careful with the grounding and the bonding connection of those elements. Okay, organic materials, they include in some synthetic materials. For example, plastic. If the plastic is made from chemical plants or animal products, that element will be considered organic material. All the organic materials are deteriorated with the time. All the organic materials are deteriorated. Inorganic elements. Inorganic chemistry is the chemistry related with the compounds, metals, minerals, and argometallic compounds. Yeah, it's basically the study of metals and minerals, inorganic chemistry. Okay, in the inorganic chemistry, if you remember, we study metals and non-metals, glasses, and ceramics. Remember that the metals are divided in alkali metals in the group number 1 and 2, transition metals in the center, and metalloids, the element located in the border, in the edge of the division in between metals and non-metals. And the ceramics is basically elements, compounds of oxide of metals with glue. It's basically oxides of metals. Those are ceramics. Inorganic materials can be natural or synthetic. For example, some pigments occur naturally as mineral, but can be manufactured in order to be converted in inorganic materials. Yes, in this particular class, we are going to use a lot of examples of those, the gel coat, the resin, the epoxy resin. We are going to use a lot of inorganic materials created in the laboratory in combination with organic materials, both of them. Okay, my friends, organic materials. Organic materials basically are polymers and wood. We are going to check the definition of polymers. Polymers are defined as macromolecules composed of one or more chemical units, one or more monomers. Those monomers are repeated like a chain. The monomers are the chemical unit that are repeated through the chain of the polymer. Yeah, the monomer is the basic cell and is repeated to create polymers. A good example is wood. Wood is basically a polymer of cellulose. Cellulose is the main component of the polymer, and wood is a perfect polymer. It's a natural polymer. And those cellulose are connected together with a lining, and lining is basically the glue to connect those monomers. Classification of polymers. The polymers are classified like natural and synthetics. In natural polymers, we have great examples: rubber, cellulose, and proteins. In synthetic polymers, We have an example polypropylene and a polyvinyl. Those are great examples of synthetic polymers, naturals and synthetics. Now we are going to analyze the internal structure of the polymers. The polymers are basically chains of monomers, and they are bonded together in order to create the polymer, the chain. The monomers are single molecules. For example, hydrocarbons. Hydrocarbon is a single monomer. Or amino acids. The amino acids is the structure of a big polymer. The process when you connect different monomers to produce the polymer is the polymerization. Polymerization is the procedure to connect monomers in a chain. Monomers are the building blocks of more complex molecules or polymers. Polymers consist of repeating molecular structures usually joined by covalent reactions, non-permanent, covalent. Example of monomers and polymers. For example, glucose, fructose, and galactose, those are monomers. And polymers are lactose, maltose, saccharose, those are examples of polymers. Yeah, the monomers are the block and the polymer is the chain. A polymer is a chemical compound or a mixture of a compound consisting of a repeating structure unit created by the process of polymerization. Great division of polymers. The polymers are divided in thermoplastics, thermosets, and elastomers. Thermoplastics, thermosets, and elastomers. And now we are going to analyze each group, and we are going to check where are located the marine products in those divisions. How the polymers are created? The polymers are created depending how they are linked together, and how is the chemical bonding, and how is the arrangement in between the monomers. And they are classified in thermoplastic, elastomers, and thermosets. We are going to check example of a thermoplastic. And what is the meaning of thermoplastic? A thermoplastic is a plastic material, typically a polymer, that become pliable or moldable above specific temperatures and solidify depending on the cooling process. The thermoplastic have a wide range of applications because they can be formed and reformed many times. Yeah, there are a lot of examples in food packings, in insulation, in automotive bumpers, in the credit cards. Those are thermoplastics. Thermoplastics. Elastomers, elastic elastomers. The elastomers are rubbery polymers that can be stressed and they recover the original form. Yes, there are a lot of examples, the gaskets, the foam. There are a lot of examples of elastomers, and we use in our industry, especially in gaskets, a lot of elastomers. Gaskets for windows, for doors, gasket in a different part of engines, water makers. We have a lot of elastomers. Thermosets. What is the meaning of thermoset? Thermoset is because cannot be reshaped by heating. It's not possible. Thermosets usually are three-dimensional polymers. Polymers in three dimensions. They have a high degree of cross-linking in between the polymer chains. They are used in the fabrication of toys, varnish, boat hulls, glues. Don't forget, the thermoset cannot be reshaped by heating. That's the key word. Alright, and thermosetting plastic. A good example of a thermosetting plastic is the resin, the epoxy resin, and the polyester resin. We are going to use two types of resins. We are going to use epoxy resins and a polyester resins. Both of them are a great example of thermosetting plastics. And now we are going to analyze each of those resins in details. Types of polymerization. Remember that the polymerization is the process of a connection of different monomers. There are two types of polymerization. There are processes that produce water at the end, and a process of polymerizations where you need added and other external element. Condensation polymerization, in which the chain growth is accomplished by elimination of water. That's very common. And addition polymerization, in which the polymer is formed without the loss of other material. There are many variants of subproducts of polymerization reactions. Okay, don't forget we have addition polymerization, and we have condensation. Normally the condensation polymerization produce water or hydroxide of chlorhydric carbon. Okay, we have those type of polymerizations, condensation or addition. Examples, we are going to analyze example of a condensation polymerization. We have dacron, polyester. Polyester is a great example. Dacron is a train made for a polyester fiber. Yeah, nylon. Nylon is another great example of condensation. They are used for a variety uses of clothing, furnishing, in industrial uses. You remember we have the straps of the travel leaf. The straps of the travel leaf in nylon. Nylon is strong. Bakelite. Bakelite commonly used in breakers, in electrical insulators. All electrical switches and the insulators of high tension connectors, high tension switches, high tension switch selectors. Bakelite is a castable fire resistant plastic. Yeah, it's used like an isolator in electrical device. Yeah, it's commonly used. And proteins. Proteins by itself is polymers of amino acid. The monomer of the proteins are the amino acid. Yeah, the amino acids are the monomers of those proteins. And condensation polymerizations, for example, of the dacron and nylon. Nylon, they are great example of condensation polymerization. When you finish the process of polymerization, the production of nylon, you have water and nylon, and the nylon can be extended to produce a lot of fibers in the clothing industry, in different type of industries. Yeah, this is the example. We have water in the bottom and nylon on top. This is one of the polymerization process that produce a subproduct. In this particular case, the subproduct is water. Properties of nylon. Nylon is the best. The polymer chain can be made over 20,000 monomer units connected together with amino acid groups. It's strong. It's a strong fiber. Is excellent for abrasion, for friction. Nylon doesn't shrink. Is degraded with ultraviolet light. This is the inconvenience. Is degraded by ultraviolet light. The nylon. Be careful with that. Okay, addition polymers. There are a lot of examples. For example, the gloves. The formation of polyethylene is coming from monomers of ethylene, and this is a great example of addition polymers. Yeah, this is the monomer. This is the monomer. Plus other one, and produce that one, and this is polyethylene. Polyethylene. Yeah, gloves is a great example of polyethylene. And other great example is polyester. Polyester. This is the resin more commonly used in the fabrication of hulls and structures, marine structures. And the monomer of that polymer is the ester, and is connected together with the MEK. The MEK is the glue in order to connect those monomers. It's the catalyst. Yeah. When you added some drops of MEK into the styrene, produce the polyester, produce the chain of styrene. This is a great example, and this is the resin, polyester resin, that we are going to use in the next coming episodes in the fabrication of stringers, transoms, windows, holes in fiberglass. Other example of addition polymers. We have polyethylene, the plastic wraps, polypropylene, the bumpers, polyvinyl, the electrical insulators, polyvinyl chlorine is the glass wrap, polyethylene fluoro which is Teflon, polyvinyl acetate, the PVA, the glue, polyestyrene, the fiberglass resin, and natural rubber. Those are examples of addition polymers. And now, in the next coming episode, we are going to analyze natural polymers.